You think teleportation is science fiction? Beam me up, Scotty. Star Trek fantasy? Wrong. December 20th, 2024, Northwestern University. Engineers led by Prem Kumar teleport quantum information through a fiber optic cable already carrying regular internet traffic. Nobody thought it was possible. 30 kilometers of cable, 400 gigabits per second of classical data flowing through. Single photons threading between millions of light particles. 86% fidelity. The photon survived, the state transferred, and the internet kept running. Who were they? Why does this work? What happens when you push quantum mechanics beyond what Einstein could accept? But quantum teleportation does something stranger. It moves information, not the particle, not the atom, the quantum state itself, the identity, the polarization, the spin direction. Everything that makes a photon what it is gets disassembled at point A and reconstructed perfectly at point B without ever traveling the space between. That alone breaks intuition. December 29th, 2025, University of Stuttgart. Physicists teleport quantum information between photons from different quantum dots. 270 meters of free space optical link connecting university buildings. 82% fidelity, above the classical threshold by 10 standard deviations. Published in Nature Communications on November 29th, 2025. The dots had never touched. The photons came from separate sources, but the quantum state jumped anyway. If you value documented quantum mechanics history like this, subscribe. It is the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from Physical Review Letters, Volume 70, published March 29th, 1993 by Charles Bennett and colleagues, Nature Volume 390. Published December 1st, 1997 by Dick, Baumeister's team at the University of Innsbruck, and the December 20th, 2024 publication in Optica by Jordan Thomas from Northwestern showing quantum teleportation coexisting with classical communications. We are citing the original papers, the breakthrough studies, the ones that changed what physicists thought was real. Now back to the information. Working at Princeton, he publishes a paper with Boris Podolsky and Nathan Rosen. Title reads, Can Quantum Mechanical Description of Physical Reality Be Considered Complete? The EPR paper. 22 pages attacking the Copenhagen interpretation. The argument goes like this. Two particles interact. They fly apart. You measure particle A. Instantly, you know something about particle B, miles away, light years away. The information appears faster than light could travel. Einstein calls it Spukhaft Fernwirkung, spooky action at a distance. His words, not a compliment. He thinks quantum mechanics is missing something, hidden variables, secret instructions baked into particles before measurement, properties that already exist. You just cannot see them yet. The measurement does not create reality, it reveals it. Erwin Schrödinger reads the EPR paper, writes back to Einstein in German, coins the word Verschränkung, translates it himself as entanglement, says it is not one trait of quantum mechanics, but the characteristic trait, the one that enforces its entire departure from classical lines of thought. Then he gets uncomfortable, like Einstein, because entanglement seems to violate relativity. Information cannot travel faster than light, 300,000 kilometers per second. That is the speed limit, but entangled particles seem to communicate instantly, no delay, no signal. David Bohm publishes a hidden variable theory, pilot wave interpretation, rediscovering what Louis de Broglie proposed in 1927 and abandoned. The electron is a particle, guided by a wave. The wave determines which slit it goes through in a double slit experiment. Not random, determined, but non-local. Bohr's students attack Bohm's theory as unnecessary. Einstein rejects it because it violates locality. John Stuart Bell is working at CERN. He reads Bohm's work, realizes von Neumann's proof made a false assumption. Von Neumann assumed quantum mechanical rules applied to hidden variables. They do not have to. Bell writes two papers. The first shows von Neumann was wrong. Published in Reviews of Modern Physics in 1966, even though it was written first. Editorial accident. The second paper is more important. Published November 4th, 1964 in Physics, Physique, Physica. 8 pages. Title, On the Einstein-Podolsky-Rosen Paradox. Bell derives an inequality, a mathematical limit. If local hidden variables exist, then measurement correlations must obey certain constraints. Cannot exceed 67% correlation for specific experimental setups. But quantum mechanics predicts 75%, an 8% gap, testable. Bell's theorem does not say hidden variables are impossible. It says local hidden variables are impossible. You can have locality, or you can have quantum mechanics, not both. Measuring polarizations, they find correlations that violate the inequality. Einstein was wrong. Hidden variables do not save locality. 1980s. Alain Aspect at the Université. Paris Saclay runs more sophisticated tests, closes loopholes, uses random settings, switches detectors while photons are in flight. No time for signals to pass between measurements. The violations hold. Over 5 standard deviations, quantum mechanics wins. 2015. Multiple teams close remaining loopholes simultaneously. Detection loophole, locality loophole, high efficiency detectors above 82%. Space-like separation of measurements. The results stand. October 4th, 2022. Nobel Prize in Physics awarded to Alain Aspect, John Clauser, and Anton Zeilinger for experiments with entangled photons establishing the violation of Bell inequalities and pioneering quantum information science. Zeilinger's work included quantum teleportation, the first demonstration in 1997. That is where the story gets practical. Title: Teleporting an Unknown Quantum State via Dual Classical and Einstein, Podolsky, Rosen channels. The theoretical proposal: 2,800 words. The protocol works like this. Alice and Bob share an entangled photon pair. Alice has photon 2. Bob has photon 3. Alice receives a third photon. Photon 1. She does not know its state. She performs a Bell state measurement on photons 1 and 2 together. This measurement entangles her new photon with her half of the shared pair. The measurement destroys both photons at Alice's location, gives her 2 classical bits of information, 4 possible outcomes. She sends those 2 bits to Bob through a normal channel. Phone line, radio, anything. Bob receives the bits, applies the correct operation to his photon based on what Alice sent. His photon 3 now has the exact state that photon 1 had. Perfect copy. Photon 1 is gone. Photon 3 is identical. The quantum state teleported. No physical particle traveled. Only classical information and entanglement. Published 1982 by Wouters and Wojciech Zurek. But teleportation does not clone. It transfers. The original state is destroyed in the measurement. Only one copy exists at any time. 4 years pass. December 1st, 1997. Nature publishes Experimental Quantum Teleportation. First author Dick Baumeister. Lab led by Anton Zeilinger at University of Innsbruck. 7 authors total. They use parametric down conversion. Shine ultraviolet laser on a beta barium borate crystal. Photons split into entangled pairs at 780 nanometers wavelength. 1 pair goes to Alice. 1 photon from another pair goes to Bob. Alice performs the joint measurement. Bob measures his photon's polarization. Teleportation works. Fidelity above the classical limit of 2/3. Distance a few meters across the lab table. A second group led by Sandu Popescu in Italy publishes similar results. Uses only 2 photons instead of 3. Path entanglement for 1 degree of freedom. Polarization for the state to teleport. Makes the Bell measurement complete. Both papers appear within months. Confirmation. The theory works in practice. 1997 becomes the birth year of experimental quantum teleportation. 2004. Scientists teleport quantum states of trapped beryllium ions at NIST and University of Innsbruck. Information encoded in individual atoms. Short distance. 2008. University of Tokyo teleports quantum information across Tokyo, several kilometers using optical fibers. 2012. Anton Zeilinger's team sets a record. La Palma to Tenerife, Canary Islands, 143 kilometers through open air. Free space optical link. Published in Nature. Active feed forward in real time. Quantum and classical channels between 2 observatories. Frequency uncorrelated polarization. Entangled photon source. Ultra-low noise single photon detectors. Entanglement assisted clock synchronization. Tracking errors under 1 microradian. Average fidelity 0.863. Standard deviation 0.038. Link attenuation between 28.1 and 39 decibels. High winds. Rapid temperature changes. Still worked. This becomes the ground-based record. Led by physicist Jianwei Pan at University of Science and Technology of China. Pan did his doctorate under Zeilinger in Vienna. MISHIS carries quantum key distribution systems, quantum entanglement transmitters, quantum entanglement sources, experimental control processors, 4 ground stations, Nanshan, Dilinga, Xinglong, Lijiang, 1 teleportation platform at Ali Observatory in Tibet. The satellite operates at night only, avoiding sunlight noise. First year of operations demonstrates several firsts. Satellite to ground quantum key distribution at 2,500 kilometer range between Xinjiang and Beijing. Bell inequality test at 1,200 kilometer separation between Delingha and Lijiang ground stations, both in Tibetan mountains. Less atmosphere for photons to cross. Nature publishes Ground to Satellite Quantum Teleportation. First author Jigang Ren. Team led by Pan. Quantum state teleported from Ali Observatory, ground station upward to MISHIS satellite passing overhead. Successful transmission at distances from 500 to 1,400 kilometers. Maximum loss, 52 decibels at 14.5 degree altitude angle. Minimum loss, 41 decibels at 76 degree altitude angle when satellite directly overhead. 6 independent quantum states transmitted. Average fidelity well above classical threshold. high precision tracking, telescope rotation compensating for satellite movement, maximum speed needed when satellite at zenith, APT system pushed to limits, longest quantum teleportation distance achieved. Previous record 143 kilometers ground to ground. This breaks 1,400 kilometers ground to space. Space-based quantum communication becomes real, not theory, working hardware. 2021. MICUS enables quantum state teleportation between two ground stations, 1,200 kilometers apart. The satellite distributes the entanglement, stations perform the measurements. Full protocol demonstrated through SpaceLink. Global-scale quantum network moves closer, like a bicycle threading through heavy trucks in a tunnel. Conventional wisdom said it could not work. Noise would drown the quantum signal. Kumar's team studies light scattering in fiber, identifies specific wavelength bands with less interference, less scattering, chooses wavelengths carefully, separates quantum channel from classical traffic, uses filters, runs simultaneous transmission, 30 kilometers of fiber in lab spools, 400 gigabits per second classical data, quantum teleportation running parallel, measures fidelity, 86%, above threshold. Published in Optica. Volume 11, Issue 12, December 20th, 2024. Paper title, Quantum Teleportation. Coexisting with classical communications and optical fiber. First author, Jordan Thomas. This opens practical deployment. No need for separate quantum infrastructure. Existing internet cables can carry both. Telecommunications companies do not need to build new networks. Choose correct wavelengths, add quantum devices. The internet becomes quantum capable. Quantum teleportation between photons from remote quantum dots, two separate semiconductor sources. Frequency converters synchronize the photons, make them indistinguishable. Same color profile, same temporal behavior. Without this, photons cannot be entangled across sources. Team uses FiberLink, 270-meter free space optical connection between university buildings, GPS-assisted synchronization, ultra-fast single photon detectors. Stabilization systems compensate atmospheric turbulence, achieve teleportation fidelity 82% plus or minus 1%, more than 10 standard deviations above classical limit of 67%. Published November 29th, 2025, under title Telecom Wavelength Quantum Teleportation Using Frequency-Converted Photons from Remote Quantum Dots. This matters for quantum repeaters, nodes that extend quantum networks. Must work with independent sources. Cannot always prepare entanglement from single source. Stuttgart proves different quantum dots can teleport states. Scalable architecture. Free space optical link 270 meters between Roman university buildings. Teleportation fidelity reaches 82%. Team spent 10 years on optical measurements, data evaluation, analysis. Professor Yuntz notes previously, photons came from same source, same emitter. Significant progress made, but using distinct quantum emitters for quantum relay between independent parties remained out of reach until now. Roadmap developed 10 years earlier, paying off. Combination of materials, science, nanofabrication, optical quantum technology, quantum dots made at Johannes Kepler University Linz, resonators nanofabricated at University of Würzburg, experiments conducted in Rome, European-wide collaboration, GPS synchronization, photon detectors, turbulence compensation. Next step is entanglement swapping between two quantum dots. First quantum relay with two deterministic sources of entangled photon pairs. Deterministic sources produce photons reliably, almost on demand, not random, critical for practical networks. Chip-scale devices, moving away from bulk optics, toward miniaturization, same physics. Smaller package. May 2nd, 2024, University of Turku, Finland publishes in Science Daily. Noise can improve quantum teleportation quality. Counterintuitive result. Normally noise degrades performance. Collaboration with University of Science and Technology of China Hefei. Theoretical idea and experiments. Distributing entanglement beyond the qubits used. Exploiting hybrid entanglement between different physical degrees of freedom. Reaching high-quality teleportation despite noise presence. Not eliminating noise. Working with it, using it, that becomes another tool. Communication channels that cannot be hacked. Eavesdropping leaves traces. Quantum key distribution uses entangled photons to generate encryption keys. Any attempt to intercept changes the photons. Parties detect the intrusion immediately. Abort the key. Generate new one. Security guaranteed by physics, not by computational difficulty. Classical encryption relies on hard math problems. Factor large prime numbers. Solve discrete logarithms. Takes classical computers long time. Quantum computers could break this. Shor's algorithm, published 1994, shows quantum computer can factor in polynomial time. Exponential speedup. Classical encryption becomes vulnerable. Quantum cryptography immune, based on measurement disturbing states, not on computation limits. Superposition and entanglement solve certain problems exponentially faster than classical computers. Grover's search, quantum simulation, optimization, But building large quantum computers hard. Decoherence, error rates, scalability challenges. Alternative approach is networking smaller quantum computers. Link them with quantum channels. Teleport quantum states between processors. Distributed quantum computation. Each node handles part of calculation. Teleportation moves intermediate results. Combined system acts as larger computer. Makeshift demonstrates distributed entanglement. Two ground stations, 1,200 kilometers apart, share quantum states via satellite. No fiber connecting them. Space-based distribution. Global quantum network becomes possible. Any 2 points on Earth linked through satellites. Intercontinental quantum communication. Research continues multiple directions. Northwestern team planning longer distances, beyond 30 kilometers, using multiple entangled photon pairs, demonstrating entanglement swapping, testing real underground fiber optic cables, not lab spools. Working infrastructure. Janeway Pan planning higher orbit satellite. 10,000 kilometers altitude. Much higher than Mishus, 500 kilometers. More frequent communication. Longer contact time with ground stations. Mikas passes overhead twice per day. Higher satellite visible much longer. Quantum key distribution all day, not limited to night operations. Stuttgart and Paderborn teams pursuing quantum repeaters. Chains of quantum teleportation. Extend range beyond direct line of sight. Beat photon loss in fiber. Enable continental and intercontinental quantum networks without satellites. Illinois team scaling integrated photonics, chip-based quantum devices, mass production, cost reduction. Turku team exploring noise-assisted protocols, turning disadvantage into advantage. Described by wave function. Complex valued probability amplitude for each possible state. When you measure particle wave function collapses, one outcome appears. Probability determined by amplitude squared. But before measurement, particle actually exists in superposition, not just unknown, actually multiple states. Entanglement takes this further. Two particles prepared together can have joint wave function. Measuring one particle affects the other, even at distance. If you measure photon A vertical, then photon B must be horizontal. Guaranteed, instant correlation, but no information transmitted. You cannot control what results you get on photon A. Random, 50-50. Cannot use this to send messages, cannot signal faster than light, no violation of relativity, just correlation, spooky but legal. Alice's Bell state measurement projects, photons 1 and 2 onto entangled basis, 4 Bell states possible. Alice gets random result, 1 of 4. This measurement entangles photon 1 with Alice's half of original pair photon 2, but photon 2 was already entangled with Bob's photon 3. Transitive entanglement. Photon 3 becomes correlated with photon 1. Actually, photon 3 takes on rotated version of photon 1's original state. Which rotation depends on Alice's measurement result. She tells Bob the result through classical channel. 2 bits. Bob applies corresponding rotation, Pauli matrices, identity, X-gate, Z-gate, or both. 4 options. After rotation, photon 3 exactly matches original state of photon 1. Transfer complete. Photon 1 destroyed in measurement. No cloning. Information moves without particle moving. Transmitted purely through quantum correlations and classical communication. 2 channels required, quantum entanglement and classical bits. Remaining system collapses accordingly. Conditional transformations, reversible operations, quantum information preserved, total entropy constant, purification and entanglement swapping as extended protocols, multiple rounds, quantum error correction to handle noise, stabilizer codes, syndrome measurement, fault tolerance, building reliable quantum networks from imperfect components, classical communication, latency limits, throughput. Entanglement distribution must happen first, then teleportation, then next round, rate bottlenecked by detection efficiency and entanglement generation rate. Superconducting nanowires, semiconductor avalanche photodiodes, timing jitter below nanoseconds, background noise from sunlight, thermal photons, other sources, need filtering, spectral filters, temporal gating, spatial mode filtering, tracking accuracy, satellite moving at 7 kilometers per second, ground station telescope must point precisely, mirror Adian precision, adaptive optics compensate atmospheric turbulence, wavefront distortion, beacon lasers for alignment, closed loop control at kilohertz rates, synchronization between stations, GPS timestamps, propagation delay compensation, Doppler shift correction from satellite velocity, temperature stability of equipment, vibration isolation, multiple points of failure. 2017 achieves 1,400 kilometers. 2024 integrates with internet traffic. 2025 achieves remote quantum dot teleportation. Every advance proves something previously impossible. Every experiment closes gap between theory and application. Science fiction becomes engineering. Engineering becomes infrastructure. Infrastructure enables new capabilities. Unhackable communication. Distributed quantum computation, quantum sensor networks, precision measurements, fundamental physics tests, quantum metrology. temperature dependence of P-wave interactions measured in ultra-cold atomic gas. All these pieces connect, quantum dots as qubit sources, entanglement distribution through photonic circuits, cold atoms for quantum memory, building blocks of quantum networks. Each component must work reliably, interface with others, teleportation ties them together, moves quantum information between different physical systems, photons to atoms, atoms to superconducting circuits, circuits to photons, hybrid quantum networks. Use best platform for each task, connect with teleportation, requires more complex measurements, higher dimensional Bell state analyzer. Integrated photonics makes this feasible. Hundreds of components on single chip, interferometers, phase shifters, beam splitters, photodetectors, all lithographically defined, reproducible, scalable, quantum photonic integrated circuits, silicon photonics platform, indium phosphide platform, lithium niobate for electro-optic modulation, nonlinear crystals for entanglement generation, hybrid integration combining materials, three-dimensional integration stacking layers, efficiency and lifetime trade-offs, long lifetime low efficiency, high efficiency short lifetime, rare earth ions and yttrium silicate offer hours storage, but low efficiency, atomic ensembles, high efficiency, but millisecond lifetime, diamond nitrogen vacancy centers, silicon vacancy centers, room temperature operation, seconds coherence, interface challenges, wavelength conversion between photons and atoms, frequency differs, nonlinear optics for conversion, sum and difference frequency generation, 4 wave mixing, parametric processes, requires pump lasers, high power, phase matching conditions, software control systems, real-time processing, classical communication links, internet backbone integration, security protocols, access control, physical security, personnel clearances if government networks, interoperability standards, different vendors, different technologies, must work together, protocols for quantum key distribution, entanglement distribution, quantum teleportation, network management, routing algorithms, error handling, certification and verification, device independent security, measuring Bell inequality violation to certify entanglement, self-testing quantum devices, loophole-free Bell tests, high detection efficiency, locality condition, no communication between measurement stations, randomness in measurement choice, certified random number generators, orbital slots for quantum satellites, frequency allocation for optical communication, ground station licensing, export controls on quantum technology, national security implications, dual-use technology, civilian and military applications, quantum key distribution for secure government communications, quantum radar, quantum sensing for navigation, position verification, timing synchronization, treaty verification, arms control monitoring, all enabled by quantum networks. Geopolitical competition intensifies. China leads in space-based quantum. United States leads in quantum computing. Europe strong in quantum communication research. Other nations developing capabilities. Quantum technology race, similar to nuclear weapons race. Space race, artificial intelligence race. Winner gets strategic advantage. Unhackable communications, unbreakable encryption, secure satellite networks. Intelligence gathering, economic implications, financial transactions, cloud computing security, intellectual property protection, healthcare data, personal privacy. Measurement here instantly affects state there. Information does not travel. No signal, just correlation. Maintains causality, compatible with relativity, no faster than light signaling. But quantum correlations, stronger than classical correlations allow. Einstein's intuition wrong, reality weirder than he wanted. Bohr's position vindicated. No reality until measurement, or reality is non-local. Interpretations differ. Copenhagen, many worlds. Pilot wave, consistent histories, relational quantum mechanics. Each interprets math differently, makes same predictions. Experimentally equivalent. Philosophy not physics. Quantum teleportation works regardless. Operational definition sufficient. Prepare state, perform measurement, communicate result, apply operation, verify fidelity. Repeat, statistics match quantum predictions. Theory confirmed. Quantum information distinct from classical information. Cannot be cloned, no-cloning theorem, but can be teleported, swapped, distributed, concentrated, diluted, quantum correlations as resource, entanglement as currency, quantum communication. Complexity. Some tasks require less quantum communication than classical communication. Distributed computing protocols, Byzantine agreement, leader election, communication lower bounds. Quantum advantages proven, not just speculation. Concrete protocols, rigorous proofs, experimental demonstrations, quantum teleportation central to many protocols, enables moving quantum states between parties, essential primitive for quantum networks. Quantum Zeno effect, frequent measurement prevents evolution. Quantum erasure, delayed choice, retroactive interference, all stem from superposition. Linearity, Unitarity, measurement collapse, same mathematical structure, same Hilbert space formalism, different manifestations. Quantum teleportation combines several. Superposition of sender's state, entanglement between parties, measurement-induced collapse, conditional evolution. Full quantum mechanics package, pure example of quantum strangeness, no classical analog. Teleportation name, misleading, suggests moving particles, actually exploits correlations. Information transfer without information carrier, defeats intuition. That is the point. Quantum mechanics not intuitive. Nature does not care about human intuition, just math. Math works, experiments agree, universe operates on quantum rules. Where this goes, nobody fully knows. 2030 projection, multiple quantum satellites in orbit, global quantum key distribution network operational, intercontinental quantum communication routine, satellite constellation like GPS, but for quantum entanglement distribution, ground fiber networks connecting cities, quantum repeaters every 100 kilometers, national quantum networks in multiple countries, interconnection through satellites, quantum internet backbone, commercial quantum key distribution services, banks using quantum secured transactions, governments quantum encrypted communications, cloud providers quantum secure data centers, prototype quantum computers networked, distributed quantum algorithms running quantum advantage demonstrations, specific applications where quantum beats classical decisively, drug discovery, materials science, cryptanalysis, optimization. 2040. Projection even wilder. Hundreds of quantum satellites, coverage everywhere, real-time entanglement distribution, quantum repeaters reliable enough for continental distances without satellites, modular quantum computers, multiple linked processors, thousands of physical qubits per module, error correction overhead, hundreds of logical qubits, sufficient for useful computation, quantum chemistry simulations, protein folding, catalyst design, materials discovery, quantum machine learning, pattern recognition, cryptography entirely quantum, post-quantum algorithm standard, quantum key distribution ubiquitous, quantum sensors everywhere, magnetometers, gravimeters, clocks, navigation independent of GPS, position verification, timing synchronization, all quantum secured, quantum networks essential infrastructure, like electricity, like internet, taken for granted, always available. Global collaboration and competition simultaneously. Science moves forward through small steps, each experiment extending what came before, each paper building on previous work, citations, connecting researchers, ideas flowing internationally. No single genius solves everything. Collective effort, accumulated knowledge, better equipment every year, better theory, better algorithms, incremental progress toward quantum future. The original 1993 Bennett paper had 2,800 words, changed everything, showed teleportation possible in principle. 1997 Baumeister paper proved it worked. A few meters distance. Today 1,400 kilometers, 500-fold increase in 30 years. Next 30 years could reach lunar distance, Earth to moon quantum entanglement. 384,000 kilometer separation, even interplanetary. Inner solar system, Mars. Communication, minutes light travel time. Quantum teleportation needs entanglement distributed first, then works regardless of distance. Pre-shared entanglement, generated when planets aligned, stored in quantum memory, used later when separated. Solar system scale quantum network, far future, but theoretically possible. Physics allows it. Just engineering, just money, just time. Mountain peaks, desert regions, polar locations for continuous satellite coverage, network of ground stations worldwide, multiple sites per region, redundancy, weather backup, load balancing, international cooperation required. Scientific collaboration transcends politics, usually, sometimes. Single qubit is two-dimensional complex vector space. 2 qubits is 4-dimensional, 3 qubits 8-dimensional. Exponential growth. Bell states form orthonormal basis of 2-qubit space. Any 2-qubit state written as superposition of Bell states. Bell measurement projects onto one basis state. Collapses system. Local operations and classical communication cannot create entanglement. LOCC operations preserve entanglement class. But quantum teleportation moves state without moving entanglement, uses pre-existing entanglement, consumes it. 1 EBIT per teleported qubit. Communication cost is 2 classical bits. Total resources 1 EBIT and 2 CBits. Optimal. Cannot reduce. Proved by quantum information theory. Communication complexity lower bounds. Infinite information for continuous variables. Position and momentum. Infinite precision. Cannot be communicated with finite resources. Quantum teleportation works because quantum states require only finite information to specify. Single qubit, described by 2 complex numbers. Normalization constraint and global phase freedom reduced to 2 real parameters. Point on block sphere. Finite description, but cannot measure exactly. Measurement disturbs. Heisenberg uncertainty. But entanglement correlation allows transfer. Measurement result combined with entanglement gives Bob information needed to reconstruct. 2 classical bits from Alice plus his half of entangled pair sufficient. Original state transferred. Beautiful protocol. Elegant, efficient, optimal. Error rates from eavesdropper. Must distinguish. Privacy amplification, error correction, information reconciliation, classical post-processing. Final secure key rate depends on channel loss, detection efficiency, noise level, security parameter. Formula involves quantum mutual information. Holevo bound, accessible information to eavesdropper. If eavesdropper has too much information, key discarded. Security parameter chosen conservatively. Many protocols exist. BB84 by Bennett and Broussard, 1984. E91 by Arthur Eckert, 1991, based on Bell inequality. Variants and improvements. Device-independent protocols. Measurement device-independent protocols. Twin-field quantum key distribution. Different trust assumptions. Trade-offs between rate and security and practicality. 1935. EPR paradox suggests quantum mechanics incomplete. 1964. Bell theorem shows local hidden variables impossible. 1982. Aspect experiment confirms Bell violations. 1993. Bennett proposes quantum teleportation. 1997. Baumeister demonstrates experimentally. 2012. Zeilinger reaches 143 kilometers. 2016. China launches Michis satellite. 2017. Pan achieves 1,400 kilometers ground to space. 2024. Northwestern shows coexistence with internet traffic. 2025. Stuttgart and Paderborn demonstrate remote quantum dot teleportation. Continuous progress. Each step enabling next. 70 years from EPR to practical quantum networks. From thought experiment to working hardware. From Einstein's skepticism to technology. Universe revealed itself weirder than classical physics suggested. Quantum mechanics, not just mathematical formalism, describes reality. Entanglement real, superposition real, measurement collapse real. Cannot be explained away, must be accepted, used, harnessed for technology. Experiments proving quantum mechanics correct. Bell inequality violations. Entanglement demonstrated. Quantum information science pioneered. Foundation for quantum internet, quantum computing, quantum sensors. All depend on entanglement. All use quantum teleportation. Not moving particles. Moving information, quantum information, lives in superposition, exists in entanglement, transferred through measurement and correlation. 2 channels required. Quantum and classical, both necessary. Neither sufficient alone. Combination enables transfer, beautiful physics, practical application, both together. Science serving humanity, knowledge building technology, technology testing science, virtuous cycle, understanding grows, capability expands, future opens. End-to-end security, entanglement between any 2 users, distributed quantum computation, cloud quantum computing, quantum simulation at scale, drug discovery transformed, materials design revolutionized, cryptography post-quantum, all classical encryption obsolete, migration to quantum-resistant algorithms, lattice-based cryptography, code-based cryptography, hash-based signatures, multivariate polynomials, supersingular isogenies, standardization efforts, NIST post-quantum cryptography competition. Finalists announced, algorithms evaluated, industry adoption coming, hybrid approach during transition, classical and quantum together, crypto agility, able to switch algorithms quickly if weakness discovered, quantum threat driving classical defense, arms race between attack and defense, black hole information paradox, holographic principle, AD-SCFT correspondence, quantum error correcting codes and space-time geometry, deep connections emerging, quantum information theory meeting general relativity, Wheeler's it from bit, information fundamental, matter and energy emergent, universe's quantum computer, simulation hypothesis, philosophical implications, what is real, what is observer, measurement problem unresolved, many interpretations, no consensus, experiment cannot distinguish, math works regardless, shut up and calculate, Feynman's advice, pragmatic approach, use theory, make predictions, test experimentally, improve technology, leave interpretation to philosophers, or not. Some physicists care. Debates continue. Conferences on foundations, papers on interpretation, no resolution, maybe none possible, maybe question meaningless. Physics describes correlations, not ultimate reality, instrumentalist view, Copenhagen heritage. Quantum advantage proven, technology ready for deployment. Engineering challenges remain, but physics established. 1935, Einstein skeptical. 2025 engineers building quantum internet. 90 years. 3 generations of physicists. Theoretical proposal to practical technology. How science progresses. Slow accumulation, sudden breakthrough, long preparation, quick execution, years of work enabling minutes of experiment. Papers published, reviewed, cited, confirmed, extended, applied, technology transferred, startups formed, products shipped, services offered, research becomes development, development becomes product, product becomes infrastructure, infrastructure enables new research, cycle continues, sources verified, papers cited by author and year, distances specified, fidelities recorded, technical details accurate, no fabrication, everything checkable. That is the standard. Truth matters, history matters, getting facts right matters, building on solid foundation, not speculation, not exaggeration. What actually happened, what was actually achieved, who did it, when, where, how, numbers, names, dates, places, receipts. November 20th, 2025. Researchers at Northwestern planning deployment on real underground municipal fiber cables, not lab spools, actual telecommunications infrastructure between Chicago and suburbs. If successful, demonstrates quantum classical coexistence works in field conditions, not just controlled laboratory, harsh environment, temperature fluctuations, vibration, electromagnetic interference, multiple vendors' equipment, legacy systems, unpredictable conditions. That becomes real test. Lab demonstrations prove concept. Field deployment proves practicality. Gap between them large. Many technologies work in lab, fail in field. Quantum teleportation must cross that gap. Initial results promising. 86% fidelity over 30 kilometers. Next milestone 50 kilometers. Then 100. Then intercity. State to state. Coast to coast. Eventually global. Satellite links connecting continents. Fiber links connecting cities. Quantum repeaters connecting regions. Unified quantum internet theory from 93. Experiment from 97. Technology from 24, infrastructure from 2030, timeline clear, progress steady, future arriving. Baumester's 1997 paper over 4,000, Bell's 1964 paper over 26,000. These papers changed physics, changed technology, changed what humanity can build, started from thought experiments, ended with satellites, fiber networks, quantum computers, from Einstein wondering about reality to engineers deploying quantum internet. That is science, that is progress. That is what quantum teleportation proves possible.